Hey everyone, this is our last section of Chapter 8, 8.5, Amortization. Amortization basically means you're taking the payment of a loan and all the interest, and you're splitting it into a series of payments. Our main examples will be like home loans and car loans. Our formula down here is a little bit scarier than normal. This is the formula for amortized loans and for finding monthly payments. It's essentially two of our old formulas put together. The left-hand side over here is the compound interest formula from 8.2, and this is the annuity formula from 8.4. And when you set them equal to each other like that, you're basically solving for what's the monthly payment I need to pay in order to pay off a loan and all of its interest within some period of time. So that'll be kind of our straightforward application of this, usually given like a home loan or something like that. What is the monthly payment you need in order to pay it off with all these conditions? And I think it's always compounded monthly. You have a set amount of time and you have an interest rate, little r. Okay. We're going to start with an example on page 423, number 19. Notice in the italics it says use a table to find the monthly payment for each loan. The table is kind of a shorthand way to get a monthly payment. They basically give you a monthly payment for like a standard $1,000 loan given the same interest rate and same amount of time, and then you multiply it by whatever factor you need to get your loan. So like for example, our loan here for Wilfredo is $13,500, and it's 12%. We want to pay it off in 4 years. So you'll go to the table, you'll find the 12% in the 4 years, but you won't find $13,500 there. You'll find $1,000, right? So this is the monthly payment for $1,000. So once you find that monthly payment from the table, you're going to multiply it by 13.5. because we have a loan of $13,500, so it's 13.5 more than the $1,000 loan. It sounds complicated, it's not really, but it's not worth our time because the TVM solver will do all of that and more. It'll actually let us find the monthly payments for loans that have interest rates that aren't on the TVM or that aren't on the table, or for months that aren't on the table. So long story short, don't worry about the table thing. Also keep in mind on my math labs, when you use view an example, it will get the monthly payment from the table. I'm going to show you how to set it up in the formula, and I'll show you kind of how to compute it from there, but really we're going to be doing this with the TVM solver. So the TVM solver, since this is compound interest, will give us all the pieces we need. Okay, so enough talking, let's dive into this. First of all, Wilfredo's buying a boat for $13,500 and he's paying $2,000 for the down payment. So the first thing we're going to do is subtract that $2,000 from the $13,000 to get a P of $11,500. So we'll take our $13,500, subtract off our down payment of $2,000, and this will give us $11,500. And this is the actual P we're going to use in the formula. The formula again, just so it's right in front of you. Should have written this down ahead of time because it is a lot. This is our compound interest formula part. This is the annuity part. As always, I want you to set this up, plug in all the pieces, but then just so I can see your setup and see basically be able to give you partial credit if you get the wrong answer. But I think the computation should be on the TVM solver because it's easier. I'm going to show you the long way to do it by hand though, just so you see at least one example. Okay, so our P is going to be 11,500. So that is the principal, that is the amount of the loan that he's going to end up taking after he pays his down payment. Little r is 12%, so it'll be 0.12. We're always doing monthly payments, so it's always going to be compounded monthly or 12 times a year, just like in the annuities. We're going to finance this for 4 years, and it's compounded monthly, so 4 times 12, or 48, will be our N. So that's the left-hand side of our equation. Capital R is what we're after, so we can kind of just copy this from the other side, right? Same R over M, same N, which I'll just call 48, 12 over 12. Okay, this is the setup in the formula. So it'll get you, 4 out of 5 points essentially. If you want to solve this by hand, here's the bad news. You have to basically calculate this entire fraction and then divide it on both sides. So you have to calculate this piece over here, which isn't too bad, then calculate this piece, and then divide both sides by that. So I'm not really even going to show much other than here's the big fraction, right? We're going to divide it over here, and we're going to divide it over here. It'll cancel out right there, and you'll get R equals whatever you get out of this side. Right? So let me, I do have some numbers for you actually, just so we can maybe follow along with this. I did calculate the top and bottom. So on the top, I got 18,540.59989. So remember, when you're doing arithmetic kind of halfway through, you're introducing rounding error. So that's why I recommend just take all the decimals you can, so that when you round at the ends, you hopefully won't see any of that rounding error. Alright, so if you calculate the top part, you should get this 18,000 something, and calculate the bottom, you should get about 61 something, and when you divide these, you should get an answer of about 302.84. 302. So this is the monthly payment he needs to pay off his motors, or whatever, he bought a boat, I think, in those 4 years. Keep in mind you're going to get slightly different answers if you use this formula versus if you use the table. But thankfully my Math Labs is pretty good about this section. It should take both answers. It should take a range of answers, in fact. So that should be the answer to this problem. Let's take a look at this on the TVM solver, because basically I want you to get to the point where you have the formula, you plug in all the pieces, and then you just jump to the TVM solver and give me the answer. You don't have to show me this whole in thing setup, by the way, any of this essentially. I'm just showing you how you would go into the calculator, enter everything, and solve for that same payment. So let's go through these things. In, since we're compounded monthly, in is in months, and it would be 48 months because it was 4 years. I is the interest rate. Don't forget to leave it as a percent, so that's 12%. Our present value is the original amount of the loan. And by actually original, I mean after the down payment, so the amount that you borrowed. So that's 11,500. Payment's what you end up solving for, so you just leave that part alone for now. Future value is 0, because notice in this formula it's just PV and payment, right? It's just the principals and payments, no future values. P over Y, C over Y are 12 because we're compounded monthly. All right, and I did actually miss something here. Keep in mind, one of the tricks to this TVM solver thing is the money that you put in and the money that you get out have to be opposite signs. So I just added a little negative sign, because if you put in a positive present value and you solve for payment, it will have to be a negative value. It's just the way the formula works. It's always, enter some, get some out. So that doesn't really matter for problems like this, because you can make I could have made this negative and got out a positive. But it matters when, let's say you have both of these pieces and you're trying to solve for n or I. If you have both of these pieces, or basically two of any of these three pieces, you have to enter one as positive, one as negative. Otherwise, when you go to solve for n, it's going to give you an error, because the formula is not working, because you're not balancing out what you put in and what you got out. So long story short, if you have any of these three pieces, if you have two of them at a time, make sure one of them is negative. Alright, the other way we're going to use this formula is for what's called the present value of an annuity. Basically, we're just going to flip it up. This time you're going to know R, the monthly payment, and you're going to have to find P. We're going to use this in a pretty specific context, just because I think it's the most relevant one, and that's with purchasing cars. So here on page 423, we're going to try out number 30. Basically, the way these problems are going to work is, it's basically how most people shop for cars in general. You go to the car lot, you want a new car, and you don't go in there thinking how much can I afford at the end, plus interest and everything. You go in there thinking, what kind of monthly payment can I afford, and also, down payment. So the way we're going to use these problems is, we're going to know the monthly payment of a car that we think we can afford, and the question is, what is the actual price of the car going to be, given some loan with its interest rate and its number of years you want to pay it off. So in this example, Pete can afford car payments of $250 per month for 5 years. What is the price of a car that he can afford now? Assume an interest rate of 9.6%. Now, when they say now, that doesn't include any of the interest. The price of the car that he can afford now is taken into account. That's how much he's actually going to borrow in his loan. So he's actually going to end up paying more off, and we can talk about how you can find that in a second. But essentially what this problem boils down to is, we're going to use that same formula, the big scary one, and we're going to plug in R as 250, and we're going to solve for P. So let's start with that formula. There we go. And we're going to start plugging in the pieces we have. We're solving for P this time, so we're going to leave P alone. Little r is our interest rate of 9.6%, so it'll be 0.096 as a decimal. Still compounding monthly because we're dealing with monthly payments. This one's for 5 years, so it'll be 5 times 12, or 60. Capital R, we know this time, it's 250. Don't forget this stays outside the fraction. Again, same thing as the other side, 0.096 over 12 to the 60. I'm only not writing it over here just so it's clear. That's how we got the 60, but really these should both be 60. So, alright, so here we go. This is our setup essentially, but in order to solve this, all we would do is take this whole side, calculate it, it'll be some number, then take this piece here, everything but the P, calculate that, and then divide this number by this number. No, sorry, other way around. This number by this number, because you want to get P by itself. And that will give you your P. Again, this is not worth doing by hand. You should do this with the TVM solver. So let's take a look at how you might do that. Okay, for that same problem, if we're going to plug it into the TVM solver, we're going to start with N, which is in months. Remember, it was 5 times 12, which is 60. Then for interest, it was 9.6%. PV is what we're trying to solve for, so let's leave that for now. Payment was $250, and again, I'm just going to enter it negative so that it gives me a positive present value, but it doesn't really matter. If we entered positive 250, we would have got a negative answer. Just our final answer in the computer should obviously be positive. No future value, and then 12 and 12 because we're compounded monthly. And then if you go up to present value and you solve for it, you should get 11,000. Oops, that's an 8. 11,876. And round to the nearest cent, 05. And that is your answer. That is, under these conditions, if you can afford a $250 monthly payment and you're going to get a loan with 9.6 interest that you have to pay off in 5 years, the sticker price of a car, which I guess technically means like after, not the sticker price, like after fees and taxes and everything, the actual amount of a loan, the actual amount of money that you're going to have to borrow will end up being $11,876.05. So that's how the present value of annuity problems work, and like I said, we'll pretty much only be seeing those with cars because that's probably the most applicable situation that we'll be in to use that. Okay, one of the other things we can do is called an amortization schedule, and this is kind of one of the paperwork pieces you'll get if you go to buy a house. It's a big table showing basically all your monthly payments that you'll end up making, and it'll show specifically how much is paid, how much of your monthly payment is paid towards interest for each month, and how much is paid towards principal, and then what your new balance will be after each month and monthly payment. It's very tedious to pay or to write out, by the way, especially if you consider that a lot of home loans, you might have a mortgage for 30 years or something like that, and that would be 360 months. Which means you have 360 lines or entries in this table. So obviously I'm not going to make you do that, but some problems will just say calculate the monthly payment, which you'll use the previous formula for, and then it'll say calculate the first 3 lines of the amortization schedule, and I will show you how to do that. So this is a amortization schedule right here. Notice it's got the first 3 months. You got your monthly payments. These are always the same, right? Because your monthly payments are just calculated up front. You'll use the formula that we just talked about, and that'll give you the monthly payment. And then for each month, you'll figure out, okay, how much interest did I earn, and then how much of the monthly payment went towards interest. So you basically take your monthly payment, subtract that, and that leftover is how much actually goes towards the balance that you owe. In this example, they owe $200,000. So at the end of month 1, they still owe $199,890, right? And so you can just see, and then you'll go back through, and I'll show you an example right now, actually. Okay, so this is on page 418. This is example 2. Some family is borrowing $200,000. They obtain a 30-year mortgage at an annual rate of 6%. which has a monthly payment of $1,199.10. Construct an amortization schedule for the first 3 payments on this loan. First of all, I want to warn you that the problems on my math labs, I don't think they actually give you the monthly payment. They want you to use that formula in the TVM solver to get the monthly payment. But that's kind of, if you look at the first example from this video, pretty much a straightforward use of this formula. So in this example, they give us the monthly payment, which I've already entered over here. And obviously they're not changing, so there we go, there's our monthly payment. First thing we have to do is calculate the interest for month 1. And the way we're going to do that is with a simple little I equals P times R times T. So for month 1, we've got our I equals PRT. Our principal is the entire amount that we owe on the loan, and that is our $200,000. So it'll be 200,000. Times R, which is the interest rate, 0.06, times T, and this is just 1 month, so it's going to be 1/12. Again, notice our interest rate was annual, so our time also needs to be in years, which will be 1 month will be 1/12 of a year. And this will just be $1,000. So in month 1, you're going to accrue $1,000 of interest that you have to pay. That's going to be added to the $200,000 that you already owe. So your monthly payment, the $1,199.10, $1,000 of that is instantly going to go towards the interest that you just accrued. So you're only actually going to pay $199.10 of the total balance. So at the end of month 1, if you take this balance, the 200,000, there we go, and you subtract off the 199.10, that should give us, let's see if I can read my writing, should give us a new balance of $199,890. Right, so this is the same table as the last slide, by the way. So yeah, so you get a new balance of that, and now on month 2, we're going to see how much interest do we accrue on that balance, and then how much of that goes towards, how much of our payment goes towards principal now. So month 2, I equals, so PRT, I'm not going to write it again. This time our P is our new balance, the $199,890. Still 0.06, still 1/12. And here, when you calculate the interest, it'll be $999. I'll be honest, it's pretty brutal at the beginning when you're paying off a loan because all of your money goes towards interest and you're earning a lot. It doesn't look this way at the end of the payments, but it's pretty bad at the beginning. So we are now going to take the balance that we have, and oops, I forgot actually. I have to show this work here. First thing we have to do is subtract our monthly payment. Subtract this from our monthly payment. So we're going to take our $1199.10 and subtract off the interest that we just accrued, and this will give us $210. This is so our interest was $999, and $210 is the amount that's actually paid on the principal. So now we'll take that $210 and we will subtract it from our balance. So $199,800 was our balance, and $210 of our payment is going towards that balance. Oops. So that will give us a new balance of $199,600.80, which is what goes up here. All right, I'm running out of room, and it's kind of a pretty boring thing to do, I'll be honest. But there you go. There's the first 2 lines. You can do it again on line 3. Obviously, you'll start with finding the interest, I equals PRT, using this as P. That interest will go right here. Then you'll take your monthly payment, subtract off the interest, and that will be the amount towards your principal. And then finally, to find the new balance, you'll take the old balance, subtracting the amount that paid towards the principal, and that will go right here. Alright, the last thing we're going to do with this formula is talk about refinancing loans. This is another thing that happens pretty common, so it's pretty relevant probably to your life or your future at some point. taking out another loan, this is what refinancing a loan is. You're basically taking out another loan with a lower interest rate in order to pay off an existing loan. So this usually happens when the economy gets better, or maybe sometimes worse, and interest rates start to fall, and the loan that you took out maybe at a pretty high interest rate, but now interest rates are low, so you can actually take out another loan, pay off everything you are owe on that previous loan, and now you have a new loan which is basically for the same amount, but it's at a lower interest rate. So that's kind of the main idea of refinancing. So we're going to do an example here on page 423. Again, check out the italics. It says, use the table, which we're not going to do. We're going to use the TVM solver. But it wants us to find the monthly payments on the original loan, the monthly payments on the new loan, and the total amount saved on interest by refinancing. Alright, so this problem, number 36, says Jamie took out a 10-year loan for $235,000, interest rate of 12%, to modernize his restaurant. After 6 years, he decided to refinance the unpaid balance of $127,960 at a rate of 8%. Alright, so the first thing we're going to do is focus on that first loan. What would his monthly payment be? Well, we're going to do that with our formula, which I'm a little bit tired of writing, so let's just jump into it. Our P is the $235,000. Oops, not equals. It's times 1 plus R over M, so that will be 12.12 over 12. This is for the original loan. It's a 10-year loan, so 10 times 12 is obviously 120. There we go. And on the other side, capital R is what we're after. 1 plus R over M to the 120 minus 1. There we go. So this is what I want to see on your paper, essentially, for work. Make sure all your pieces are plugged in correctly, you got the right formula, and then jump to the TVM solver. So if you solve this in the TVM solver, you should get 3,371.57. This is the original monthly payment on his loan and part of the answer here. Alright, so now what's going to happen though is he took out a 10-year loan, and after 6 years, notice he has 4 years left to pay it off, 4 years left of paying, he decided to refinance the unpaid balance. Alright, so after 6 years, he's going to take out a new loan of that unpaid balance, the $127,000 or so, and that new loan is going to be at an 8% rate. And we're assuming here that he still wants to pay it off within 10 years, so the new time is the amount of time that he still had, the amount of time that he had left to pay off his loan. So 10 minus 6 would give us 4 years. So we're going to go back. This is now our refinance loan, and we're going to calculate the same thing, but our P this time is now going to be 127,960. I did it again. Sorry. Times 1 plus R over M. This time, this is our new loan. R is 0.08. And that is the whole point, by the way, folks. If your interest rate isn't lower than before, there's no reason to refinance. So that rate has to go down here. This is at 4 years, so it'll be 4 times 12, or 48. Then on the other side, same thing. This is 48, I said. There we go. This is what the problem looks like in the formula. So all the pieces are correct and set up in the right spot. Jump to your TVM solver, plug everything in, and this time you should get a monthly payment of about $3,123.89. Well, there we go. Obviously, our monthly payment went down, which was the whole point of this the refinancing in general. It doesn't look like it went down by a lot, right? It looks like, it is about $250, which is a lot. But especially since you have 48 months to pay it off, that's $250 you save for about 48 months. So that's the last part of this problem, by the way. It says, find the total amount saved on interest by refinancing. Well, we pretty much just said it, right? Let's see. If we subtract these two monthly payments, you'll find out how much you're saving per month. And then if you multiply that by 48, which is the number of months you have left, that should be how much you're saving. So let's do that. We'll take our 3371.57 and subtract off 3123.89. And let me do that real quick actually, because I didn't. And I got 247.68. That's how much you save per month. And since you're saving that for 48 months, you're going to take your 247.68, multiply it by 48, and you should get 11,888.64. That is a lot of money. And that's how much you would have been paying anyways if you wouldn't have refinanced. So this is our last answer here. This is the amount that you save by refinancing. So that's it for this section. That's it for refinancing. Keep up the good work. Let me know if you have any questions, and make sure you get in there and get that TVM solver down, because as you've definitely seen in this section, it saves you a lot of time, and it's going to do the bulk of the work for especially these big nasty formulas here. Let me know if you have any questions, and I'll see you next time.